Right. Hello, everyone. Welcome to the SolidWorks walkthrough for this RIT IDSA 3D workshop weekend. I'm the IDSA president. We have Kim here who's going to be giving us our SolidWorks walkthrough. Feel free to ask questions, obviously, those who are joining us here today. Thank you so much for being here. And Kim, I'm just going to hand it off to you so you can take it away.
All righty. For those of you who haven't used SolidWorks, aren't familiar with it, it's a parametrically driven solid modeling CAD package. So some of you are just here for the Rhino demo. That's a surface modeler, which it's sort of like making all your models out of sheets of paper. And you end up with what looks like the same result, but inside, mathematically, it's hollow. There isn't solid. So if with Rhino, you drill a hole in something, then you have to add the inside surface of the hole. I believe, unless they changed it, wasn't able to sit through that, but that's the way it was. And with SolidWorks, you drill a hole in a block, and it's as if you just drilled a hole. There's a bottom and a cylindrical sides on the hole you just drilled. And the other thing that's different is that it's parametrically driven. So rather than the geometry driving what the dimensions are in rough terms, the dimensions drive the geometry. So once I drill a hole, and Jack, you just sat through the demo. And is there anybody here that's a Rhino user? Okay.
I'm not a heavy
Make
user.
a mistake until you publish this, right, Jack? So as I understand, at least when I was using the software 100 years ago, if I wanted to move the hole, I essentially had to patch the hole or fill the hole or undo the hole and then drill another hole. With anything that's parametrically driven, the parameters drive it. So if I want to move the hole, I just change the dimension of where the hole is. One of the things that people take issue with SolidWorks is it's very geometry heavy. You start most everything with a flat sketch, and then you move that sketch through space and make something that's three-dimensional. You can either extrude it, you can revolve it, or you can loft it. So you've got one shape here, another shape here, and you just create a filled surface solid between those two. And that presents some challenges for some people, but I actually like the way it works. I used Rhino before this and really liked it, but once I got into SolidWorks, I really have a hard time going back to something that's not parametrically driven. So what I'm going to show you today, or attempt to show you today, is creating a pair of sunglasses. And unfortunately, I had a client call me on Thursday with a rush job that's due on Monday, so I didn't get a chance to go through this. So bad news is I may trip through some things. The good news is that you'll actually see the design process for real here. So what you want to do when you start with this, I tried bringing in a 3D head that I snagged from GrabCAD, but it was so data heavy that it just slowed everything down. So what I've done is I've brought in two images of Mitch. This is Mitch here. I use Mitch and the bike helmet in my SolidWorks class to have students create a three-dimensional helmet in SolidWorks. So I'm going to use these same two pictures as a reference for the size of the glasses that I'm creating. And what you're going to see here, usually when somebody demos some software, they'll give you a canned package that they've done 20 times before, and they'll just step through it, and it looks so easy. Well, the first time you go through, even with most any software, regardless of how easy the software is to use, there's a lot of design steps that they just sort of skip over. So the actual design process can be kind of time consuming because you actually have to think about what you're doing And a lot of it, I'll tell people that 90% of your time when you're designing a real project, if you haven't experienced this already, 90% of your time is actually going back and making changes, editing, and figuring things out. So you can see this. I just did this uh, uh, just before this, and I'm looking at this, and I've got this curve up here, and I'm realizing that I wanna take that curve and tilt it forward a little bit. So I'm going to have to do some edits. But what I'll do is I'll go back to ground zero and start this whole process so you can see what it takes to get at least to this point. And if I have time, I'll start creating the frame as well. So one of the things with eyewear in particular, whenever somebody starts to make eyewear, they invariably start by designing the frames. And I'm pretty sure no matter what software you're using, you don't want to start with the frames, because the lenses themselves, whether you're dealing with sunglasses or eyeglasses, the lenses have a certain shape and thickness to them, and that frame has to fit that. So what I suggest to my students when they're making any kind of eyewear is start with the lens, that shape, that sort of defines everything else, and then create use those as a reference and create the frames around those. So SolidWorks is geometry, it's parametric, and it's also history based. Rhino doesn't have history. If you want to go back in time, you have to just actually start. I don't even know if you can go back in time. I think probably typically what people do is what I used to do is you save like every half hour or so, you make up another backup copy. So if you make a major mistake, you go back to revision 13 and start over from there, which sounds horrible, but it's really not that bad. Typically, the second time you go through something, whether it's in SolidWorks or Fusion or Rhino, the second time you go through it, you're experienced and it goes much faster. And you just get much better at the software. So with this, I can go back in time and you can see, I will tell you one of the cool things about Fusion is that when you make the left half, it will make the right half at exactly the same time. So you get to see exactly what you're doing. With SolidWorks, what I do is I'll put a mirror on the end, and as I'm working, I can just turn the mirror back on. It'll flip it over, but it's almost as good, but it's not real time. Real time is awesome. So what it is, I created, well, let's go through it in the correct direction. Oops, nothing. Before the Big Bang, there was nothing. Uh-oh. A little lag here. Okay. Imported to two sketches, and this is important. You get those, the two images, and you want to get those the correct size, front view, side view, because you're going to base the real geometry of your eyewear on that. And I didn't have a top view because we didn't need it for the helmet, so I just looked at the width of his head and the depth of his head, and I drew an approximate ellipse, so I would have roughly the size of his head from the top view, because that's going to help determine the shape of the eyewear. Now, this doesn't really work. I actually need to take a photograph of the top of somebody's head or have some 3D geometry in here, because nobody's head is shaped like an ellipse. So when I finally get to 3D print these frames, they're not going to fit anybody unless you're seriously deformed. All right, so let's go here. Then we do a surface revolve for one side. And these are, you can have generally three types of what they call blade sunglasses. So that means that the left lens and right lens are all one continuous surface, right? And those shapes are typically almost always one of three shapes. Is that they're a cylinder, means it's completely straight up and down, and then a continuous cylindrical surface across the front. They can be spherical, which means it has the same curve top to bottom as it does left to right. And then there's also torus. It means they have a tighter, torus is donut shape, basically. So it's just the section of a donut, and that's what I'm using here. Whoops. That's what I'm using here is the curve up and down is slightly different than it is side to side. I did that partly because it's going to give me more freedom in changing the shape. And then there is a fourth option. That's if you go to two separate lenses. Usually those are almost always a spherical surface, and the center of the sphere is essentially centered on the center of the eyeball, so that you're always looking through the surface perpendicular. Your line of sight is always perpendicular to the surface of the glass. But that's mostly for eyewear. For sunglasses, it's not so critical. So once I have the surface, I create by sketching this out. One. By sketching, I'll sketch out. Whoops! Sort of skipped a step there. Come on. Yeah, definitely got some lag here. I don't think I have a really, oh, you know what it is? I don't have the best, fastest internet connection here. And with SolidWorks and Zoom, things are going to slow down a little bit. All right, so let's edit the sketch. Yeah. All right, that looks scary, complex to people that aren't used to this, but it's really it's really what I like about SolidWorks. It's very precise. It takes more preparation up front, but the reason I like that, and I don't mind doing that, is as long as you have a logical thought process and you're thinking about what the important elements are, and what changes you're likely to be making later on, it's very easy to go back in and edit. And that's 90% of what you're doing in design is making changes and tweaking it to fit your design intent. But also when you show it to your design manager, you end up making more changes. You show it to the client, you end up making more changes, and then you get it out to potential users, your prototypes. They're going to have suggestions, and you're going to come back and make more changes. So being able to change things readily and precisely is pretty important. So we'll go back and step through this process, so you can see how I got to where I am here. All right. And Zoom is covering up my controls here. I didn't like that. Got the pinwheel of death here. Yeah. Not sure why that's doing that. I was tempted to come into school to use the computers there, so I didn't have to worry about this. I think I maybe should have done that.
I guess if we have a second, do you want to talk about some of the things that you appreciate about SolidWorks, why you use it over other programs?
Well, I think that probably the big thing is precision. There's a lot of the challenges with working with the high-end software is the is the level of complexity to get into, but a lot of products I've worked on are really complex, and a number of them I just would not have been able to do. There were projects that I just would not have been able to create without software like SolidWorks. Yeah, this thing is not cooperating. I may have to just reboot here, and if I lose you, I'll try to reconnect. I do apologize for this, Jack. I'm not sure exactly what I did that has caused this, but we'll. Oh, well, that was interesting. That fixed it. Okay. All right. Let's get out of here. Any questions so far? All right, let's do this.
I don't know if you were going to get to this. Do you mind quickly breaking down the form of the sketch?
Yeah, actually, we're going to recreate the sketch here.
Okay.
All right. So the way this starts, we'll start with the. Hi. Wow. Yeah. All right. So right plane sketch. And yeah, it's parallel to give me trouble. Yeah. They got an upgrade that I haven't upgraded yet. It's got some bug fixes. I think I'm going to restart here before I get drawing.
Could I just ask, what are you because you said parallels, you're a Mac user and then you do the,
Yeah,
do the,
I use parallels exclusively on my uh, all my computers for my job, and this is not a really good ad for parallels right now.
my mom
Yes, normally no trouble at all.
usually, I think my parents use Boot Camp, so I don't know how the two
Boot camp
softwares
would
compare.
definitely work better because then you're in you're running the software native. Yeah. And unfortunately, I will give you the full scoop here. Unfortunately, um, uh, Mac is going to their own proprietary computer chip, which will no longer allow this. So I'm going to. It says parallels is not responding. So
Do you need to restart? I'm getting ready for it.
right. Okay. All right, so so what I did is we've got options here for center point, tangent, or 3-point arc. I'm doing a 3-point arc, and I can sort of put that where I want it. So as we're doing this, I'm not just drawing arcs. I'm thinking about what this is going to look like when I get all done. And do this and. So that's roughly where I want things. Put it here. I wanted to go around the nose, and I also wanted to just clear the forehead here. So that's about the shape. And as you're working, you don't just randomly put dimensions on. You find something that's close to it. So this is close to 2.6, and I know just from past experience that 3 is not. And you know what? I'm going to put this at 2.5. It doesn't look too bad. 2.5. And then I'm going to define where the center of this is. Now these all takes, all this work takes a little bit of step-by-step process, but each one of these dimensions is something, a variable that I can modify later on. And also design intent is important. So as I'm thinking this through, the logical thing is to just locate where the center is. That's really irrelevant to how all of this looks. So what I am more likely to want to do is define this, where this is. So I'm going to undo that dimension. And oops, 2 steps, 2.5. Because I may, one of the things, always thinking about what's going to change. So one of the things that may change in the future is this radius. If I decide once I do a rendering of this, I think that's too tight or too big a radius, I'll change it. But when I change it, I don't want this to move. So if I locate it by the center point here, and I change this radius, it's going to move away from the face. Bad thing. So now it's important that I dimension, and I'm just using the origin of the file as my starting point. And then shift click. If I just click this, it'll automatically snap to center. If I shift click, it goes, well, click. It's not working. There it is. Yeah, okay, so that goes right to the tangent point there. And that's pretty close to 3.6. And this is a delicate thing, and it's at this point, it's a little close to the forehead. So I'm going to change this to 3.7. And also, as I'm thinking about this, I'm going to thicken this at some point. I'm going to probably thicken it forward so it clears there. Actually, I'm going to take this a little bit farther. That's still a little close. 0.8. Yeah, that'll work. 2.5. And the other thing I'm going to do at this point is I'm going to extend this beyond what I need, because, oops, we need to, oh, lost my dimensions there. So that locates it horizontally. Now I need to locate it vertically. Let's go 0.8. And then I don't need to dimension these next things, but if I dimension them without going all the way back to sketch level, I've got dimensions floating around that I can edit at a later time. So again, I'm going to reference them off the origin just because that's a handy place to reference from. S key gives me the shortcut to dimensions. I don't know. Yeah, there we go. Let's go, I'm going to go bigger than I need to, 1.5. Let's go to 1. And I want this tip down just a little bit. And this may be a little bit extreme, but I won't really know until I start creating the form. And then at this point, I need to pick a line that this surface is going to revolve around. Sketch, center line. I'm going to bring it, I'm going to take a guess at the width of his head here. this is also going to come from the front surface. Shift click. And this is for the, we've got, this is a torus we're creating, a section of a torus. So this is going to create this radius across the front. We've got the sketch creates the radius vertically, and then this dimension creates the radius on the horizontal plane. So let's go to 3. Yep. All right, so we can see what happens here. All right, so we go to surfaces, revolve. We're going to do a blind revolve. We're only going to do it through 40 degrees. And just so I know whenever I go back into a file how it's set up, I generally create objects to the left and then mirror a dimension on the left, just so that I know, so my files, any file that I create is set up consistently. And the reason I start on my left is because we read left to right. You just have some bit of logical reason for that. Let's go. There it is. All right, so that's not long enough. So I can come back here and change the angle, or I can just grab this arrow and pull until we got something that's, oh, that was a little bit too far. I'm gonna, let's look at this. Yeah, that's a big pair of glasses there, so we're gonna dial that back a little. Let's see. That's about there. We can always make adjustments later on, but we'll start with that. So Control-1 gives me front view. And just so I can see, I'm going to do a sketch on here, but I want to be able to see the face that I'm referencing. So we'll right-click on this. This computer also doesn't like using SolidWorks and Zoom at the same time. It's overheating a little. All right, so right-click, change transparency. You can see what we're doing now. And as I'm looking at this, I'm thinking that this, even though it looked right over here, I think this might be a little too extreme. It comes into the face a little bit sudden here, although we may be cutting that away. So I may need to go back and tilt this bottom out a little bit. Those of you who are wondering about this whole thought process I'm going through, you sort of signed on up for this for the rest of your life. This is the thought process when you're designing is just trying to think a couple steps ahead, a little like a chess game, and then understanding that if you've set things up properly, you can always go back and edit and modify things. You know, I think I might change this a little bit. So let's go back into the sketch level here. And we're going to lower this down. These little blue dots in SolidWorks allow you to change things by, I've got to go into the sketch. Edit sketch. Yeah, let's go. Let's go 0.5. Yeah, I think that'll work a little bit better. Exit the sketch. Interesting. All right. Back to control 1. That looks a little better. Brought this out a little bit. All right, so on the front plane, sketch out using 3-point arc again. And I want this to be tangent to the other half, so as we're doing this, these two are going to be vertical. And we'll decide what height we want this to be above the eyebrows. That's a dimension. Pretty close to 1. And the numbers here I'm putting in, you could just do all of this by eye and leave it. But the numbers, particularly when you do tech drawings, I very rarely do tech drawings, but tech drawings are for people. All the numbers are in the software. So if you're sending it to 3D print or having something cut with a CNC mill, the computer does all that for you. The numbers are just so people can see and make suggestions that this gets moved down 0.1 inch or up 1.1 inch. So all of that. And this is one where also we're thinking about design intent again, is I could put a radius on this, but what's more important to me, at least at this point, is the height. So I want to be able to change the height of this. You know, actually, I am going to dimension this because I do want to give it a nice round number, like 7. But I'm also going to put on a dimension here to see how much this raises up. In this, it's not going to let me, actually, it might let me do that. Yeah, before I do that, I'm going to set how wide this is. Let's go 2.6. And this, it's not going to let me do all those dimensions on there because I've got competing dimensions. So this one's going to be driven. And this just gives me an idea as I change this, how much this is stepping up. So I can go to 8, move it 0.43. All right, then I'm going to go in and get another 3-point arc. I'm going to locate the, actually I'm going to do this with an angle because I want to be able to rotate this so I can pivot it out, pivot it in easily. I'm going to create a just a construction line there as a reference, and actually don't even need that. That's just so everybody watching has a better idea what's going on. We got this. We pick a center point of rotation, pick a line as a reference. This 4-point star shows up here, 4 arrows. I pick this and I can set my angle right here. So we'll set it to 6 degrees. And we will set the, this radius is, set it to 1.7 because I want it a little tighter than what I'm showing there. Then we'll put another one on the bottom here. And before I go much farther, I'm going to put the nose cutout in as well. Let's see. Put a center line here. Here I'm going to use a tangent arc, which can come off either tangent or perpendicular. And then I can come off with another tangent arc in the other direction. It's actually a nice tool. And I could have done this with splines as well. Everybody loves splines because they're so so intuitive and you just lay them down. But it's like designing something precise with a noodle. Only use a spline if you really need a continuously variable curve and an ellipse, or an ellipse won't do it for you. They're easy to put down the first time, and then they're hard to work with after that. Because there's the SolidWorks, any parametric software, Fusion I would put in the same category. They're very good at working with massive amounts of math. You have no idea what's going on in the background in these applications, but it is massive. So I would suggest always meet your software halfway and try to keep things simple. And generally speaking, doing things the simple way, it's easier, it's faster, it's easier for the software to do. And you know what? A lot of times it ends up looking better. When people are using spline curves, they have a tendency to use too many control points. The more control points you have, the less control you have. So fewer control points. If you're doing a loft with a whole bunch of cross sections, fewer cross sections you need to use, the better. Go 0.15. Radius on this. What's his nose radius? Let's go 0.25. This is, call this 1.5. And so there's a couple of different ways I could define this. I'm going to put in a little construction line here so that I can set the angle of the nose piece. Because when somebody tries on the 3D print, they're going to have a suggestion that did I bring out the angle a little bit, bring it in a little bit, or change this radius, and this is going to allow me to do that. So again, always thinking about what you might want to change later. Let's go with 25 degrees. The other thing I'm going to want to change potentially, depending on the look, because what I would likely do, real world, I would likely bring this into a 3D CAD model, or the model of a head, and see how it fits on that before I 3D print, just to get one more check. Very simple, easy to do, before I spend the time and money to do a 3D print. So, so I'm likely to want to move this up and down, so I'll just give a reference here. And it can be to really any point. I'm going to pick this so that it doesn't move. Let's go 0.9. If I want to go more than 0.9, I'll probably want to extend this bottom edge down a little bit, which is not hard to do because of the way it's set up. And anytime, I'm a adamant believer in getting rid of blue sketches, and we want everything defined so that later on when you make a change, things don't just blow up on you. And also, when I want to make a change, I've got a dimension that I can make that change with. Let's do this 0.4. And it's still blue, so I'm going to guess it's because of the radius. Let's go with a 4. There it is. We'll close this off. Yep, I'm liking the looks of that. Oh, little warning that I haven't been saving. I've been talking instead. Save. Okay. Okay, so I've got my sketch back here on the let's go to this, on the front plane, and it's right in line with this surface that I'm going to trim. So let's do surface trim. There are surfaces. Trim surface.
trim tool. Is this sketch? Surface to trim. Is this surface? Oops, reverse. There we go. All right, let's get rid of these sketches here. So now I've got this surface floating out in space. We'll take this and thicken. We'll go thicken. And it's looking for the surface to thicken. It's this. I'm going to thicken forward so it doesn't get too close to the face. And let's go, instead of 0.1, let's go 0.08. We'll go to features, mirror. The mirror surface will make that right plane. It goes right through the center plane here. Then instead of doing features, we're going to mirror bodies because it's a little bit more, well, it's much more reliable. Always do that when you can. Click. And because I had my sketches tangent to the center line or perpendicular to the center line, everything comes out clean. So let's go Control 1. Let's turn sketches back on. See how this fits Mitch. Mitch is looking awesome. All right. Let's see what it looks like from the top. Control 4. Okay, so it comes a ways away from the face, but I think the person's face tends to be flatter than what you would see here in this ellipse, so I think we're probably good in that. All right, so I'm going to save this again. Go Control 7, give me a perspective view.
How frequently should you be saving your files?
I save my files anytime I complete something that I don't want to have to do over again. There's Alex. There's Alex's picture. His voice is coming. There he is.
Here I am.
All right. All right. Well, I would say, all right. So unfortunately, I had some technical difficulties here, Alex. So I didn't get to my frames here. My office computer did not look like working with SolidWorks and Zoom at the same time.
Ouch. That has happened to me.
Yeah. So, all right, let me just step through what I would do here. I got a minute and a half. Let's get rid of this. So what I was saying earlier is that what you want to do is people, when they want to make eyewear, invariably they start with the frames and then try to figure out how to fit the lenses in it. And what you need to do, create the lens first, because that really defines the shape and the look of the glasses, and then go back and create the frame. So I would be, there's a couple of things you could do. You could make a cross section and then sweep it along this top edge. Or if you wanted to have a little bit more option for creating things, you can take these surfaces, offset, and then trim them to one another, and that becomes the basis for creating the frame. So it's exactly set off from this, and then you actually use the lens to cut away from the frame, and all good. So next time we do this, Jack, I think I will work from an RIT computer, so I don't have to worry about this. I'm going to have to talk to my computer tech guy to see if I can get my money back for what he did on my last machine there.
No worries. We're still figuring out the kinks of making this work.
Yeah.
Does anyone have any questions before Kim heads off? No, good.
I'm good. Thank you.
Yeah, I just want to say also from taking classes with Kim, it's always really important. It's not just about knowing all the answers. It's about being able to ask the right questions when it comes to CAD programs. So really just understanding what you can do, then you know how you can look for it. Because there are so many tools that you have available to you. You know, you can use Google and YouTube. There's no problem with that, and finding out how you can do something specifically. So this is really good way of looking at an approach to a project, and you may not know exactly how you want to approach it, how you want to fix a problem. And it's always good to sort of view the problem as what you can accomplish from it, and then going to look at the specific CAD techniques you can use to do that.
Yeah, I would say a couple of things that are important is just asking questions. If you're working on something and you're thinking there ought to be an easier way to do this, chances are there's an easier way to do this. So ask the questions. And the other thing, and probably more important, is rather than just focusing on making a product, because so if I assign this in class, making a pair of sunglasses is not the important thing unless you're going to work for a sunglass company. The important thing in all of this is not just learning the software, but learning the most efficient way to use the software. So I would stress for everybody, if it takes you a few minutes more to figure out an easier way or faster way to do something, now's the time to do it. You want to develop good habits now, so later on you're not doing everything the hard way. Yeah. So we'll end there, and I'm eager to watch the Fusion demo here.
All right, thank you so much, Kim.
No pressure.
Yeah, we're gonna have Alex on in a sec to do Fusion 360 demo for us. Thank you so much, Kim, for doing this for us. Really appreciate it. If anyone would like a little bit more information on SolidWorks or anything else, you can always get in touch with us through our Instagram. And we can always, if you're an RIT student, we can find someone to connect you with. If you're not, we can just help you out there. So we do, want to remain in contact with you guys and help you out there. So please follow us on Instagram and do that. We're going to say goodbye to Kim. And thank you so much for doing this. And really appreciate everyone who's able to join us.